Okay, so there are different ways of manage reactive energy, actually reactive power energy. So one is synchronous alternators, second one is synchronous compensators, then third one is static VAR compensators, right? Then fourth one is which is going to be static capacitors, right? Static capacitors. So these all four items will come into at different places, right? So that's how we are aligning it, right? So we will see that where it is used and etc. So you know that in alternators, by altering the excitation of the alternator, the active power can be injected and the voltage profiles to be modified that. So in alternator, there is an option called, there will be a other, there is something called exciter. By altering the excitation of that alternator, reactive power can be injected, right? And voltage profiles to be modified. That we can do it. And second one is there is a synchronous motors which will be running no load and it will be in synchronism with the network. So basically, when you run that motor at no load, it will give the reactive power support which is needed to the grid. It will be added actually. Okay. So this is kind of one side of these things. Nowadays, a lot of BIS network is coming up, right? Solar plant and base, all those things, right? Battery energy storage system. Now, earlier and all, your grid is very strong, right? Your grid is very strong. That means there is a only thermal power plant. There will be a generator. They have got both, which means active power and reactive power. Like everything is there. But whereas here nowadays, no, your grid short circuit ratio may not be that much sufficient. So basically, there is a like whatever that energy what we are producing from solar and base, no, it's a direct active power. There is no equipment to uh, generate reactive power. Though the reactive power is literally it is not useful, but it is not considered as a active power, which means uh, how we can put that like the nowadays the grids, no, like solar plant and space, it will be full of active power, but there is no additional support. That reactive power support is not there. To do that, what utilities or companies what they are doing it, there is something called to give this reactive power support. They are adding a something called synchronous condenser, which is nothing but your synchronous motors, right? Which will be connected to the grid. That will act as a support. I mean reactive power support to the grid actually, right? So this is one thing. Static VAR compensators. There is something called uh, you know static VAR compensators. So basically, which will have uh, power electronic devices. So this is generally you could see that in a solar plant in the 33 kV level, all those things, these you could see it. So here what you will have, actually there will be a power electronic devices. So again here either through which you can either import reactive power or inject reactive power. I mean import or export both you can do it. So that is what called static work compensator. These kind of equipments which you could see it in the 33 kV side, in the solar plant, maybe in those kind of renewable energy sectors, you will see this actually, right? Because sometimes we may have to switch on, inject. Sometimes we may have to, inject reactive power into the grid. Sometimes we need to, draw the reactive power from the grid. So depending upon the situation, right? Because in solar plant, there are different life cycles. In a daytime, it will produce power. In the nighttime, it has to draw power from the grid itself. So the scenario changes in the night time, right? So you need to look at all these things with respect to the solar projects and etc. Right? That is called static work compensators. Right? You see that ESC, it allows step-by-step control of the reactive power delivered by groups of capacitors, whereas TCR is a continuous control of reactive power drawn by the inductors, and it is possible, right? So there is this technology is available that you could see it. Since you have a power electronic devices, you can do the complete control of it. You can regulate it as much as you needed it. That is one possibility. Then there is something called static capacitors, which predominantly used in the medium voltage and as well as in the LV side, right? So as you know, capacitor banks, there are two plates. In between, there will be a dielectric medium in which electric, energy, it will be stored into that, right? So that is the one, right? So these are the four stuffs that where these are the four type of devices where it can support reactive power point of view, right? So this is very important. This is very important. So these capacitors generally it will come on the LV side or maybe in the 11 kV or something like that, 11 kV, 6.6 or 3.3. Okay, so in those areas. Whereas the previous one, no static power compensators, if you look at, no, it will come in that 33 kV side, wherein the like areas like where solar power plant, and in those areas you might see these actually, right? So this one, the synchronous motors running and load, where in the big networks, where if you feel that the reactive power support is not sufficient and certain particular voltage, then at the time they will connect, because this motor requires huge. You need to. It's like again a generator only. So it occupies quite a lot of space, and you need to give separately excitation and etc. All those things that you need to do it. So which means when you have these, generally most of the time this will come in a grid level projects only, right? So it will be used to support reactive power in a grid level, right? So only it will support only it will when you run this, you are injecting the reactive power into the grid. That's what it happens, right? So this is synchronous, compensators, right? I mean, sometimes they call it a synchronous condenser as well. That is one thing. Then synchronous, alternator, that in the alternator itself, you have the capability to control reactive power. Like either you can inject or draw the reactive power. So that is one. Those four are the topics that are equipments that supports reactive power actually, right? So you can use it at various, locations. This is a very important piece of equipment. I know, because these three, it will be a big equipment. Capacitors generally in the 11 kV and LV side, very often it will be used actually. Maybe not just in a typical industrial environment, these capacitors are very much used actually.